I'm very happy to introduce to you Yair Weinberger, our co-founder and CTO, who will be our speaker for today's webinar on GDPR. He has been with Alooma for the last about 4 years and has been involved with data pipeline for the last 15. So without further ado, I'll hand it over to Yair. Yair?
Thank you, Tasha. So our agenda for today is to talk a little bit about GDPR from engineering perspective and specifically data engineering perspective. So I'm going to just give a quick overview of GDPR. And again, I'm not a lawyer or a legal person, so but this is try to make that information as accurate as possible, and then focus on the implications on our data pipelines, on our data engineering, on how we store data. And at the last part of this webinar, I want to showcase Alooma and showcase how many of the issues can be tackled using Alooma very, very easily. And that part is going to be fairly technical. So at that last, if you came here to see some code, stick around for the last part, because it's going to be here. So just a quick overview, GDPR is the General Data Protection Regulation that covers the handling for personal data for EU citizens. Now, it covers EU citizens even if they reside outside of the EU, which means that I've heard all kinds of suggestions like, let's block all traffic from EU and get rid of the GDPR. Well, unfortunately, this doesn't work, or at least doesn't comply with the regulation. And this regulation is being effective, starting to go in effect at the end of this week. So we have about 3 days before it's in effect. GDPR has 6 principles, which are outlined here. We need to make sure that we are transparent about which data we store, and that we are letting our user know and agree to us storing data in a very clear way. The purposes of which we store data are limited. We have to minimize the data footprint or the personal data footprint that we store. We have to have the data as accurate as possible. We cannot store it for forever. For example, we have to give the users the ability to delete their own data. And we have to maintain confidentiality of the data, so no data leaks, and we are, by this regulation, in order to comply with it, we are obligated to maintain the data confidential. Now, it's not optional. I mean, unfortunately, it's not something that we can opt out of or we can opt in of. It covers all data for all citizens of the European Union, and every company that wants to avoid, it could be fines, it could be a legal process, must comply with that regulation. So it has far-reaching implications on pretty much every tech company that wants to use data. In this specific webinar, I want to focus on the last 4 parts of the last 4 principles of the regulation, because the first 2 really sometimes resides on the way where we communicate with our users, where we tell them, hey, I'm going to use cookies, or I'm going to store this and that data. And this is usually from data engineering perspective, not always as relevant. So going to focus on the last 4 principles. And let's start by defining personal data. So personal data means any information that can identify a natural person. And the regulation calls it data subject. And this is very wide. I mean, of course, it's name and address, an email address, a phone number, even an IP address is considered related to an identifiable natural person. Mobile device ID, debatable, but if you want to be completely on the, let's say, on the safe side, probably should consider mobile device ID as personal data as well. And of course, as always, the recommendation is to err on the side of caution. But as you can see, the definition of personal data itself is very wide. So I'm sure everyone who has a data company or who stores data does store those types of data points or those type of fields on the users, and sometimes it's even essential for the business. So this is how personal data is defined. What's the impact? So we are allowed to store personal data. That's the good news. We don't need to delete everything right now, all IP addresses and all emails from our databases. But it's now really limited. We need to make sure that we don't store it without a necessity. And that's actually, I'm not sure it's very well defined. A person is entitled to ask for their stored data. So they can ask you, hey, company, what are you storing about me? What data you have about me? And they are also entitled to request a deletion of their data. In order to mitigate this, we as data-driven companies, we want to try to anonymize personal data when possible, which means we can hash it to something that's irreversible or encrypt it to something that is reversible, but still only if we have the keys. We have to know where we store personal data, because if someone asks us for the data, we need to be able to tell them what we store. So we need to know where we store it, and we need to allow both retrieval and deletion of that data. So again, not easy to do, because as you know, big company has a lot of data sources, data lands in multiple different places. Not very easy to tell, hey, where is this email field for, in every system in each and every source. So let's try to make a wish list for data engineers. First is we want to know which applications are storing personal data, and also which vendors. So where in our, let's say, maybe data sources and places we pull data from, where do personal data exist. We of course also have to make sure that all of our vendors have a data processing agreement with us, or a DPA. We need to know then, when we store the data for analytics or for any other reasons, we need to know where is it stored. So not only the fact that application MySQL transactional database stores personal data, but we need to know which database, which table, which columns, exactly what holds the personal data. And then delete, anonymize, encrypt personal data, which, even if we look at the event sourcing pattern, which means, okay, let's have immutable set of events, and then all of our processing is done on top of those events. This has become very common now with Kafka and S3, and if we need to delete data, that's not good enough. We cannot store immutable raw data forever and ever anymore. So we need to be able to delete, as data engineer, delete, anonymize, or encrypt personal data. Hopefully even auto-detect new fields with personal data. If a developer now starts sending an email or any field that contains personal data, we need to be able to detect it and make sure, again, we handle it properly. And we are now also, this have always been a wish list for data engineers. The data will always be accurate and to maintain data integrity. But now we are required by law. So it's not even enough to, it's getting a higher priority on the wish list again. So and these are not easy things to ask for, because if I'm sure if every one of you will think about their own data pipeline and think about the different components and the different elements that receive data and how the data goes through the pipeline, it is pretty difficult to to achieve that wish list, and sounds like a lot of work. So I do want to talk a little bit about Alooma, and I will actually start with a quick general demo of Alooma, just to show the Alooma product itself, because I'm sure most of the listeners are not familiar with that product. And then I will go into specific of that wish list just presented above. How can we achieve those with Alooma? And of course, they are achievable without Alooma as well, but just how easy it makes it to find out where the personal data is stored and to change it, etc. So Alooma itself is a data pipeline as a service. Goal of which is to create one service that handles all of the data pipeline needs. So it's able to ingest data from hundreds of different data sources. It is able to get that data into a message queue, make sure that no piece of data is getting lost. And now the interesting pieces, two very interesting pieces of Alooma, especially with relation to GDPR. One is the code engine, or the ability to change the data as it goes through the stream. And the other is the mapper, or the schema catalog. So the ability to actually have the entire schema and schema changes stored in a schema repository that can be accessed either through user interface or via an API, and understand all of the schema changes in the schema fields. And actually for GDPR, that mapper is essential because it will be able, and we'll show that very soon, how exactly we can tell where the PII data is. The last piece is the restream queue, is how to handle errors. So I'll move over to an Alooma demo to show the product itself, and then we'll show some code samples as well. So this is an already set up Alooma system that you can see in front of you. On the left side, you can see the different data sources that are currently pulling data into the stream. On the right side, it's currently pushing data into Snowflake. Snowflake is one of the most popular cloud data warehouses and a partner of Alooma. And once, of course, if you just beginning to set up Alooma, this screen is completely empty. And what you can do here is you can add different data sources. So if we want to, let's say, ingest data from Salesforce, for example, you'll just click on Salesforce, connect authentication with Salesforce, and choose our object. So I'm not actually going to go through the entire process of adding a data of adding a Salesforce input, but you get it, I hope. It's simply a couple of clicks, and once those are done, the integration is being set up. Now, every one of those can be set up as what we call one click or automatic. So one click means let Alooma automatically discover the schema, let Alooma automatically create the tables on the Snowflake side, and let Alooma do everything for you. Or you can choose manual, which means I want full control over the data, full control over the call. Once something is set up already and data is streaming, we can actually even click on it. We can see live samples. We can see what have gone through this. So a few hours before this webinar, shipped some events. So we can see them streaming. We can actually see samples of what is streaming inside the data. So this is very, very useful to understand what's going through our pipeline. Once data starts streaming, we can see it in the mapper. We can actually see what fields are coming in, and that is the schema repository that I described earlier. What fields are coming in, what values do those fields have, and even live samples from the data itself. So just for example, if I'll click on a specific field, I should be able to see everything that has been going through that field. So for example, these are the different countries and where data has been streaming from which countries. This is very useful to understand which fields do I have in my data, which columns are they populating on the other side in the database, which data types, and of course change them as well. So I can change properties to stream into something else. So maybe I want to flatten that JSON and put each inner field in a column of its own. So all of those, of course, are passable through the mapper. Another thing that the mapper does, and that is related to data integrity and consistency, is the mapper would pre-validate every piece of data that's coming in. So before data is being loaded into the target, into the data warehouse, or being processed, the mapper will validate that everything conforms with the schema. And if something is out of the schema, it will either try to course correct and coerce it into the schema, or if it is impossible, it will land in the restream queue or the error queue. The restream queue looks like this. It's just an interface that can show us every event that couldn't go through. We are able to filter on the error type or the event type or on the source where data came from. And then once we fix the error, once we take care of it, we can even get the specific event that failed. And actually for me, I've been a data engineer, as Tasha mentioned earlier, for many, many years. For me, this is a godsend, because if the pipeline breaks, one of the most difficult things is to understand what broke, which event exactly broke my pipeline. Here it's just coming in out of the box immediately. The other piece that's important actually for GDPR, and I want to mention, is the code engine piece. And the code engine piece is actually the ability to run code on every event that's coming through. So just for example, something that takes an IP address and enriches it into geolocation data. So I'm going to grab a sample here and run that code. And you can see I had the IP address in that field, the client IP field. And now all of a sudden, city, country, region have been added. So just a simple gRP enrichment. But as you can imagine, changing data on the stream have many use cases, and we'll touch on one of them very soon. And of course, dashboards that can show us which data is streaming, when it's streaming, if there were any errors, if data have made it through to the data warehouse or failed. So in that case, we streamed some events, they made their way to the data warehouse with a very little amount of errors. Then we cleaned those errors. So it is very straightforward to understand what's going on with the pipeline itself, what's the situation, and what's the status of the pipeline. Again, all of this, of course, is also accessible from API, not only from the user interface. So it's very easy to take those metrics, pull them into Datadog. The last thing is the live view, and for that, I hope the animation actually will go through the screen sharing. But you can always go to alooma.com/live if it doesn't. I'm actually going to look at the production system live view just so that you can see it in action. The live view shows all of the events that are coming through the stream live, and we can actually take one of them and take a look at it, at the data in the event itself. We can filter, so I can filter in my email, for example, and since it's a production system, if I'll go to the Alooma website, I'm already logged in, I should see the event coming in really quickly. So let's say I'll just go to the Alooma website and I'll start filling up a form. And that event immediately is available here. It's like, as you can see, conduct form open. So this is also very useful for debugging and also a nice eye candy if you just want to hang it on the wall. But so this is Alooma in a really like a very, very short overview or description of Alooma. Let's go back to GDPR. And okay, we have this very nice looking tool. How can we use that tool for being better GDPR compliant? So the first thing that's interesting for us is let's ask ourselves a question: where do we have PII data in the mapping itself? And I'm actually going to move to shift over to code. I hope this is easily visible. Let me just make sure it is. And in this code, it is using the Alooma client library. Of course, it's available. Anyone can install it just by doing pip install Alooma from Python. And what that code does, let me try zooming in a little bit. All right. What that code here does is it goes over the mapping and searches for a specific string in the field name. So this is something very, very simple. Let's say we have email address, email in the field name. That makes sense. It will be private data. And again, of course, it is just the beginning, but this is still a very good indication. So if we just take a set of strings like IP or like email or like user ID or address or zip code, and just search the field name that are coming in, we have a very high chance of finding out where our personal data lies. And what this code does, it initializes an Alooma client going into that gaming demo system. It goes over all of the event types. The event types are the green parts in the mapper. Let me just go back. Usually an event type represents a table on the target data warehouse. So in that case, we have two different event types that are called Clumsy Bird and Python input. So that code will go over those event types, and it will, for each and every one of them, it will go over all of the fields, and for every field, it will look, in this instance, for the string client IP. Now I know this is a very specific string, and that's on purpose, but let's just see how it works. So I'm going to run this code. If you can look at my output, I'm going to make it bigger now. It now connects to Alooma, and you can see it found the string client IP in 2 fields, and it already tells me, hey, look, you have in the event type Python input the field metadata.client IP, and it is mapped into that table. Python input metadata client IP. So I already know from the wish list we described above, I can already tell where my PII data is, the personal data is, in which table, where it is mapped to in the target data warehouse, and where it exists in the source. Now, granted, I cheated a little bit because I already knew the name client IP. If I would search for just IP, I would find, because IP is not a very distinct string, let's try that, you'll be able to see that I will find a bunch of fields that sometimes may be unrelated. So we might want to do, so this is a good start. This is a great start. Actually, well, here only IP was also good, but if you imagine, thousands of different tables with thousands of different fields, not always you'll be able to correctly guess the name. So this is a good start, but let's take it one step further. Let's say we want to look in the data itself for something that looks like an IP. Now, we all know how an IP looks like, right? 3 digits, period, 3 digits, period, 3 digits, period. So this is a simpler, I switched over to the next level, which is searching in the samples themselves. This is a very simple regular expression, as you can see here, that just capture IP address. We called it in the very creative name, IP address finder. And since Alooma stores samples from everything, what we're going to do is we're going to try and find matches for that string in all of the values, which is a little bit more interesting. Now we don't need to know the field name. We'll already get the suspect from the value itself. And you can imagine this is easily expandable. A regular expression that finds an email address also not very complex. An address may be a bit more complex, but also not extremely. So it is pretty easy to write those regular expressions that find data automatically. So what does this code do? Again, goes over all of the first, like we did before. We initialize an Alooma client, and we get all of the different event types. And in this case, we go over all of the event types. We use the Alooma API to get samples from the data itself. So this is the get sample function. And for every sample, we try to match a regular expression for all of the values. So we go over all of the values, and this is a little bit of an ugly recursion to go over the values, but then let's see if I can find it. Let's see if I can find the data itself. So, and by the way, that return somehow got injured, it doesn't matter. The result is being populated throughout that function. So I'm going to run, so let's run that sample, and here it's going to be even more interesting. So it's going to search in the sample and try to find the suspects. And as you can see, it says, okay, we found the suspect in the event type Python input. The field is metadata client ID. So now we didn't tell the name upfront. And the value that was suspect is this. And as you can see, it indeed looks like an IP address. It's not very surprising. It's just regular expression matching, not very sophisticated code here. But since we have all of our schema repository available via API with samples, it makes it very easy to just run this very simple code and immediately understand, and this would work on 2 tables, as in this demo, or on 2,000 tables. Easily understand where we store all of the IP addresses, which table, which field, everything. So that's great. What do we do with it now? We found a way to identify all of the IP addresses in the code or all the emails. What can we do now? So here comes the code engine. I want to go back to the code engine and highlight a module that I created. That module actually is also, we have a blog post we published in November. I'm sure Tasha can share it on the chat, about how to anonymize private data on the stream. This was long before GDPR and was used mostly for healthcare data, but it's very relevant here as well. So this is a very simple model that what it does, it gets a field and hashes it and gets a list of fields to anonymize. So I'm going to, and of course the main, the clumsy bird model is calling that. So it will go over all of the fields to anonymize and we'll hash them. And currently I didn't find any private data yet, so there is nothing here. So I'm going to get a sample. And as you can see, I have the client IP here. I'm going to run the test, and since I'm not doing anything with it, client IP remains client IP. But now let's say I want to anonymize it, and luckily I already know where that lies because it told me, our code told us, hey, that field is a suspect. We're going to add it to the field to anonymize. And let's run the test again. And now, as you can see, client IP is anonymized. So all we did was we added that field to the list, and all of a sudden, on the stream, all of the events are getting an anonymized IP. And let's say we find a new suspect, we can just as easily add it to that list and have that anonymized as well. So no private data will even hit our data warehouse. And if we want to encrypt it, we can switch that hashing function with an encryption function that's reversible. Now, imagine, and that last piece, okay, now we want to auto-detect it on the stream ongoing. We can, again, take that code with the regular expression that we just showed that runs the search, and you can just put it in the code engine as well. That's simple Python. You can put in the code engine everything you can code in Python. So once it's in the code engine, we can just find suspects. When we find suspects, we can raise an exception, have it wait for us in the risking queue, or if we are more brave and sure of a regular expression, we can even automatically add those fields to the list from the code engine itself. So we are able to handle the personal data almost completely automatically. So if we go back to our list, to our wish list, which is what we've just shown, we've shown how we can use the schema repository to find out where personal data is stored. We showed how we can delete or hash or encrypt personal data on the stream itself, and even how we can auto-detect personal data in the schema. The data integrity comes generally from Alooma, from the Alooma exactly one semantics, from the Alooma ability to not lose any event, and these are just general tenets of Alooma, even unrelated to GDPR. So this was I know it was a lot to take in with some deep code sample, and we'll share the code sample in just as well if someone is already using Alooma and just want to use them. But I'm happy to answer any questions you might have.
Great. Thanks, Yair. We did have a few questions come in. One is, how secure is Alooma? What security practices are we using?
Yeah, that's a great question. So Alooma does not. Let's start at the first rule of security in Alooma is that we do not store any data. So the only thing that Alooma stores are metadata and samples. Those samples are being rotated. So when data is not being stored, it's already a big step towards not leaking data if we don't store it. Then in terms of security itself, Alooma has implemented some compliance and the certificates. So Alooma is SOC 2 Type 2 compliant. Alooma signs HIPAA BA agreement, so can work with HIPAA compliant companies. And of course, Alooma is GDPR compliant as well, again as required by law. And a lot of thought has been put around sandboxing the code engine, for example, and creating a very secure environment for the data to run.
Great. Can you explain a little bit of the tech stack under Alooma?
Yeah. So the basic Alooma is in the basic tech stack is Alooma uses a bunch of open source tools and with a combination of in-house stuff. A big component in the Alooma architecture is Apache Kafka. Apache Kafka is being used as the message queue, and all of the events that are being received are going to Apache Kafka. And Kafka is the main way to scale is to create a partition Kafka, which enables more parallel processing of the data that's coming in. The stream processing itself is a lot of it is custom made. It is used to be based on Apache Storm and Trident. We are now in the process of migration into Kafka Streams. The integrations themselves are mostly homegrown, built a lot of the integrations. So that's maybe the biggest component of the tech stack.
Great. And it says in the demo you use Snowflake. Do you, can you send data to other data warehouses or other targets?
Yeah, so definitely. Actually, I didn't show it in the demo, but Alooma can send all of the raw data into S3 as well. So this is already supported out of the box. Alooma also supports currently, in addition to Snowflake, Amazon Redshift, Google BigQuery, and MySQL. We are adding support, and soon will be available for Azure, Microsoft Azure SQL, and or a C format in S3. So let's say Frestor/Athena on top of S3.
Okay, it says another one is I saw Salesforce as a target. Can you sync from a relational database to the accounts object in Salesforce?
Yeah, so generally, Alooma syncs any relational databases by reading the transaction log. And then once the transaction log is being read, the data can, essentially every transaction that happened on the relational database is arriving to the Alooma data pipe. Now, in terms of target, Salesforce as a target is supported through the code engine, which means we do have a module that can write to Salesforce, but Alooma will not automatically create objects in Salesforce. So the mapper/schema repository is not part of the Salesforce support currently. However, if the only goal is to sync records into account object, yeah, that's definitely supported. It is even something that Alooma does itself. We are syncing data from our own relational database into our own Salesforce instance, in that case, to the opportunity object.
Great. Does Alooma only do real-time data?
No. So Alooma supports both batch and real time. We do try to do everything as real time as possible, but some things are batch in nature. For example, let's say we want to read a table from a relational database, and we only want to do it once every 8 hours because it doesn't make sense for us to run the table more often. Then Alooma supports that as well. So you can schedule batch operations in Alooma, but the Alooma, one of the core principles behind the Alooma architecture is try to convert everything to streams as much as possible.
Great. Looks like another security question. What type of data security does Alooma provide?
So I'm not 100% sure I understand the question. Alooma itself, in terms of how Alooma handles data, I hope that's the meaning of the question. So Alooma, as I mentioned, does not store data only temporarily, but even when the data moves to Alooma, it's always encrypted at rest. The communication protocols are always encrypted as well. So when data is being moved to Alooma, it's encrypted. Once the data is being processed, Alooma itself does not provide any data security, as we don't store the data, and we don't have any control over it anymore.
Great. Another question looks like what type of alerting is available?
Sure. So generally, every alerting, there are system-generated alert and user-generated alert. So system-generated alert, Alooma decides automatically if something goes wrong, and it has 3 severity levels: info warning, and error. And for each severity level, it is possible to choose how to receive those alerts. So it can be immediately as they happen, or it can be in a digest. It can be read through API, or it can be pushed. And then code engine itself can generate additional alerts, which are the user-generated alerts. So, for example, if you want to do some kind of anomaly detection on the stream, and then fire an alert if you find an anomaly, which is rooted in business logic, not on data warehouse being down, for example, then that's logic that you can write in the code engine, and it will be embedded in the general alerting system. Some of Alooma's customers have already published open source projects to push metrics from Alooma to Datadog. So if someone wants to use Datadog and get Alooma alerting through that, that's possible as well. PagerDuty and PagerDuty as well.
Great. Looks like maybe got one more question is being typed here. Easy one. Is there a trial option for people to try out Alooma and specifically around GDPR?
Yeah, so definitely there is a trial from Alooma. The model for Alooma is that we provide for everyone listening in $500 of free credits to try Alooma. Alooma pricing model is credit based, so it's pay for what you use. And trying out Alooma can be done for free just by signing up at the Alooma website on the big Get Started button.
Great. Awesome. On behalf of Yair and the rest of the Alooma team, we'd like to thank everyone on the line for joining us today. We hope you enjoyed the discussion and look forward to having you on future webinars. And keep an eye out for the recording. We will be sending that out shortly. Have a great day, guys.
Thank you.